sustainability of the world's critical services and infrastructure. Our technologies transform complex data about people, places, and assets into meaningful information and capabilities for better, faster decision making in public safety, utilities, defense, transportation, and the government sector. I will begin by introducing our speakers. We have Niladri Banerjee, who is the senior manager and has been associated with Hexagon since April 2008. He has done more than 100 on-site international and national trainings and installations of the Hexagon geospatial softwares. Another speaker along with him is Sumit Thapa. He is also senior manager and has been with Hexagon for over a decade now. He has worked closely with almost every national mapping agency, various government R&D organizations, and numerous educational institutes. Before handing over to our speakers, I would like to mention that if at any given point you have any questions you would like to ask, you may please enter it in the questions box. Our presenters welcome your questions and will address them later in the presentation. If in case we are unable to get to all of the questions by the end of our live session, someone will reach out to you and help answer that question. And just to let you know, we will also be sharing the recording of this webinar after the session. Now over to you, Niladri.
Right. Thank you, Divya. So before I start, am I audible to everyone? Am I audible, Divya?
Yes, Niladri, you are. Yes.
Right. Thank you. Just to start with, uh, just to start with, I would like to welcome everyone, all the honorary faculty members and the research scholars and my beloved students who have joined for the webinar today. So the topic is geospatial technologies for New India. So definitely the topic plays a very vital role today, what we are hosting for. As you know that since all the mission mode projects which have been introduced since last 1 decade, so the industry's focus is no more on a particular software or a product, something like that. So basically, we are here just to give you an idea that what kind of solutions we can provide, being a premier geospatial company or a global geospatial leader. So in next couple of slides, I'll be covering that what are the projects that we are looking into, what will be the future projects, and what are the solutions that we'll be providing or already we have provided in different projects. And to cater all those solutions, what are the softwares are there within the Hexagon Geospatial bucket? Because we from Hexagon strongly believe that the future of geospatial technologies is strongly lies on the current aspirants like you guys who are the students of geoinformatics or civil engineering or who are the research scholars. So with that spirit, I would like to start the presentation of today. So can I have the next slide, please? So about the the agenda today is about Hexagon. So I would like to give you a little brief that what is a Hexagon, what are the portfolios that we are offering, then what would be the educational portfolio of the softwares that we are offering. Then we'll go for the Hexagon solution for civil engineering, Hexagon solution for town planning, and WebGIS technologies for smart cities, what we are providing. And then we'll have the Q&A. So if you see our agenda, we have not mentioned any kind of software specific products, or we are not focusing any kind of softwares. Yes, we will be talking about the softwares and we'll be seeing some of the software, screenshots, but mostly they are considered as the part of the entire solution. So again, as Divya said that whatever question and answers, we'll be taking all the questions in the Q&A sessions. And if you have any questions during the presentation, please feel free to post in the chat box. We'll answer them once the presentation is over. So about Hexagon, can I have the next slide, please? So just it is very important to understand that who we are. So Hexagon is the technology solution provider. So we are having a global reach where more than 20,000 employees are working in the 50 countries. So, and we are serving the wide range of industries, wide range of varieties of technologies. Not only we are confined with the core geospatial domain, also we are supporting those domains of IT where geospatial is a strong backbone, like smart cities. So we are strongly research and development focused, where we regularly invest 10 to 12% of our net sales into R&D. So basically, as you know, the more and more we move into the R&D, more and more we'll invent the solutions, and more the solutions, I mean, more and more we'll be able to solve the problems with the newly developed solutions. So to do that, we have 3,800 dedicated brains engaged into R&D sectors. And we have 3,700 active patents over our hat. So those are purely our IPR, that the technologies we have invented and we have patented for us. And we come from a very strong and sound financial background, wherein we have 3.8 billion euros in sales. So the figure is very important. Why the figure is very important? Because if simply I ask, or anybody ask, that from where this 3.8 billion euro money has come. So the money has, that much money has come because the global people globally who are working in the field of geospatial technology, they have trusted on our solution. They have opted our solution. We have sold to those people and we have earned the money. So this huge amount of money has come from a huge amount of global and Indian customer base. So that itself proves that how strong technological foundation we have in the geospatial domain and the those domains of IT where geospatial technology is a backbone. So Hexagon consists of many flagship brands like Eras Imagine. So most of you, I think, know or heard the name of Eras Imagine. Eras Imagine is the global flagship software for your image processing and remote sensing. Then we have a famous geospatial solution brand called Intergraph. It has got several software portfolios under the utility segments. GeoMedia Professional is one of the flagship GIS softwares under the Intergraph belt. Also, we have Leica Geosystems. The civil engineering and survey people are very accustomed with the name. So Leica Geosystems is also one of the brands, big brands of Hexagon. So now we have very recently we have acquired the Lucia technology as well, where we can go for all the geospatial solutions we can build which are dependent on the GPU. Now, the entire Hexagon division, Hexagon is divided into two major groups. The geospatial part, one is the geospatial division and another is safety and infrastructure division. So in which deals with the public safety and utility, wherein geospatial basically has all these kind of geospatial solutions, enterprise and cloud platform enable. So or entire, so if I just summarize, so Hexagon provides all kinds of cloud-based enterprise enabled platforms, as well as it provides the hardware solutions, as well as it provides the desktop image processing and photogrammetry and UAV data processing solution. So Hexagon provides one-stop all kinds of geospatial needs. So can I have the next slide, please? So in India, so almost you can see from the map, almost all the major cities, Hexagon is having their office. Most important point to note in these slide is that Hexagon has its one of the couple of biggest R&D centers in the world, which are situated in Hyderabad and Pune. So where over 2,000 employees are constantly working. So basically all these products you see are the mostly the software products like GeoMedia, photogrammetry, ADAS Imagine, and couple of other software products. They basically are being built in India. and sold across the globe. So we are constantly, developing all these kind of products in India only to cater the mainly the Indian customers need and to cater the, geospatial need of various Indian mission mode projects. So can I have the next slide, please? So as I said at the beginning, that Hexagon is uh, catering many different industries. So what are the industries and what are the field where Hexagon is providing the solution? So we are into the smart cities and smart nations. We are into the transportations and port management. Among some of the applications of core GIS, which is forestry, agriculture, then water management. Also, we are into the safety and security business. And also we have one our very strong foundation or very strong footprint in the field of defense. So one question may arise or one curiosity may arise that how can we serve all those various domains? Because the key answer is that we have cracked one of the greatest challenges that is being faced by the entire geospatial industry. What is that great challenge? The challenge is known as the GeoOps challenge. What is the GeoOps challenge? Let me explain you in a simpler way. The GeoOps challenge is that all on the left hand side, all we have are our data sources, which are very familiar to us, like some of the GIS layers, some of the UAV photogrammetry or UAV imageries or aerial imageries or satellite imageries or any kind of data sets which you collect from the survey part. Now, on the right hand side, we have all the demanding agencies who are demanding the solution constantly from the system. So they are demanding, like for example, in incident management, any kind of incident management agencies or multi-utility management agencies or any connected system like GIS and SCADA integration or any kind of emergency service agencies. They are demanding constant data or constant information from the system. But the data which we acquire generally is of not of today, is not of now casted data. It is previously acquired, maybe a week before or 15 days before or a fortnight before. So can it is it possible to develop a solution that once your data is generated or once you acquire the data, immediately that data can be put into a decision support systems, dynamic DSS, and automatically that particular system will be displayed or enabled to all the right hand side agencies who demand a now casted data. Is it possible to bring all those data to be converted into an intelligent analysis where all these agencies can put a query and get an immediate answer to solve their problems, and that will help them to take the immediate action without wastage of any further time. So all our cloud enabled enterprise platform provides those kind of fluidic analysis dynamic dashboards with the help of the GIS database data layers, UAV data layers, remotely sensed data layers, or any kind of connected field devices, so that all these agencies can get immediate answer and they can address their problem. So that is how we are able to, serve all these different domains and all these different various vertical industries. So on the bottom right corner, some of our prestigious clients who uses our product day in and day out, like ISTO, NSDI, then UP 112 and MP Dial 100, etc. So can I have the next slide, please? So these are certain, government projects where we are involved as one of their, solution providers. Through somewhere we are directly involved, somewhere we are involved through the prestigious MSIs who are integrating all the various needs and various components like JJM, Namami Gange, Sagarmala, Amrut, Bharatmala. So these all are the mission mode projects and where we are serving day in and day out to our prestigious clients. Somewhere they are central governments, somewhere they are state governments. So can I have the next slide, please? So educational product portfolio. that we have. So we have several educational portfolios in terms of the Power portfolio, Luciad portfolio, and Map portfolio. So most important, or one of our famous education portfolios are known as the Power portfolio. So inside that we have producer suite, provider suite, and platform suite. So all these producer, provider, and platform suite, what they create. Producers suite. Can I have the next slide, please? Okay, before I go to next slide, then let me just quickly explain about the Luciad portfolio and Map portfolio. So in Luciad portfolio, we have couple of products. So what is the main job of Luciad portfolio, where we have mainly the usage of the graphical GPU based system. So where many objects, you can think of certain spaces. You think of a space where many objects are moving and we have to track their location. We have to get the real-time data and we have to analyze the fact and create a DSS out of that. In those domains, Luciad is one of the fittest solution. Like for example, if we think of a aircraft movement controlling agency, where it is controlling, taking the data from the multiple aircraft, changing their routes, changing their positions, advising them about the weather which is coming up in their route, so that the flight can be deviated and posted into a safer route to reach their destination safely. So where all these kinds of operations are moving, so Luciad portfolio is one of the fittest platform. Map portfolio, where we have some of the analysis, dynamic analytics. We have to create certain dashboards. So those kind of cases, we have the Map portfolio. But in our education portfolio, where we are giving more focus, is the Power portfolio. So can I have the next slide, please? Yeah. So Hexagon Power portfolio, basically it caters the core domain of remote sensing, GIS, and photogrammetry. So we have a solution called Educate. In that educational bundle, we provide the different remote sensing software in form of ADAS Imagine. We provide the GIS software in form of GeoMedia along with its different educational bundle. Now, what is the job of the provider suite? So provider suite, basically, they just provide the data or deliver the data through a proper and easily accessible solution to the end users. Nowadays, we are having the UAV. Nowadays, we are having very, many small satellites who are having frequent revisits and provide many more images, right? So there is a need that how do you handle the data set? How do you handle those large geospatial data set? So the provider suite basically provides a geospatial catalog through which we can manage our all this kind of geospatial data, be it UAV data, be it vector data, or be it a data which is coming from the field in from all these kind of survey instruments, or any kind of connected IoT systems. And on the right hand side, platform suites provide certain platforms where we will consume the data. Some of the users may like to see the data in the mobile app. Some of the users, they would like to see the data on a desktop clients. Some of the users who would like to see the data in a browser, web-based browser. So for all of them, we have all the fitted and necessary solutions. So can I have the next slide, please? So once I replace all these, domains with the softwares with which we are catering the need of that particular domain, we can read it as the remote sensing software domain. We are catering with the ADAS Imagine. Now the GIS analysis domain, we are catering with a desktop GeoMedia software. So which is our flagship GIS software. The photogrammetry domain, we are catering with the Imagine photogrammetry. Or if we talk about in case of definitely aerial and satellite photogrammetry. And if we talk about the UAV photogrammetry, then we have a software called Imagine UAV, with which we are basically catering that UAV photogrammetry domain. Now, once we talk about the data management and delivery domain, so we have a flagship software called ADAS Apollo. So more NSDIs, most of the state SDIs, all the forest departments where data management, data cataloging, data delivery, along with certain web-based analysis is required. So they have opted our ADAS Apollo platform. It is up and running in most of the state forestry and state SDI, SSDI, and NSDI departments. Then once we talk about the enterprise solution, so here we have for all those who are who wants to consume the data, various data in a browser format, we provide the GeoMedia web map. Those who wants to have it in a desktop based thick client, we provide them with the GeoMedia Smart Client. That's a software solution name. And those who wants to have it in their mobile, those who wants to go for a field check, cross check, field data collection, and immediately submit to the server, like this kind of a connected system, for them we have something called GeoMedia Mobile. So these are our entire portfolios, geospatial software portfolio, and mostly in the core desktop educational bundle, we provide the ADAS Imagine, we provide the GeoMedia, we provide the Imagine photogrammetry. Now, couple of very important thing that we would like to deliver to you as a message or an information. They are, we have certain bundles of the educational portfolio, like we have 5 user bundles, 10 user bundles, like that, and so on. So in a 5 user educational bundle or 5 seat educational bundle, where we provide the 5 number of ADAS Imagine, 5 number of GeoMedia, and 5 number of Imagine photogrammetry. So all licenses are concurrent licenses. So simultaneously, ADAS Imagine licenses, GeoMedia licenses, and photogrammetry licenses can be used. And along with that, depending on the user's need, and rather the departmental need, and with a mutual understanding to us, we also provide the student home use license. That's a very unique proposition in terms of the education, where we are allowing, so far so long, as you know, all the licenses that used to be procured by the faculty members or the departments, that must remain within the premises of the educational institution. But during the time of lockdown, we have started proposing the student home use license, which officially can be installed in the student's personal laptop, wherein the student can carry out that educational license to his home or to his own comfort, and he can use it. So that's the official thing now. So when you procure the perpetual license of the this kind of educational bundle, 5 user, 10 user, 15 user, along with that, without any extra cost, we are also providing certain number of student home use license, which we can at the time of the event happens, where we can discuss with the department based on their need, and based on our understanding, we can agreed upon a mutual a number, and that number of license we can provide for the student home use. So that will extend the facilitation of the online classes, or if a student needs to have a project work to be done at his end in an extended hour, that will be very much helpful. So with this, now I would like to hand over the presentation to my colleague, Sumit Thapa. So Sumit, stage is yours now.
Right. Thank you very much, Niladri, and good afternoon to all of you. So now Niladri has already shared you about how geospatial technologies are basically benefited with Hexagon and how we have an offering in educational. We are just going to cover now what all we have in education a little bit in depth, its applications. So that will cover. So for remote sensing in educations, we have our flagship product called ADAS Imagine. So it will be used for your urban planning, civil engineering. So it will be useful in supporting your decision making decisions, and you can create different outputs from this, which will be one of the inputs for different decisions. So like elevation models, land use land cover maps, satellite images, UAV images, point cloud data sets. So these are some of the data sets that you can use and create some meaningful decision out of it using ADAS Imagine. which is so one of the key functionalities of ADAS Imagine is image enhancements, how it basically enhances and how it extracts information out of image. And secondly, you can also go for photogrammetry and ortho rectification, so which is a very essential tool for your any planning event. You can generate elevation models out of it, which is again very useful for understanding the topography of any area. And these are some of the key functionalities that we cover in ADAS Imagine. And these are the product offering as part of the educational pack that is available. Uh, but we can also have some additional add-on products that can be shared as per your need. So ADAS Imagine Professional, again a flagship product for image processing. Then we have expansion pack, which is additional add-on features like automatic georeferencing, 3D visualization, chain detection. So these are some of the add-ons that will come along with expansion pack. Then we have VR Mapper, which has some of the workflows designed for oil, gas, and mineral industries. Then we have Imagine Photogrammetry within this pack, which is useful for creating orthomosaics, generating your elevation models, very high resolution elevation models. And now with the help of DSM extractor, you can also generate point clouds also. So using your stereo images, you can generate point cloud data sets. And then terrain editor, in case your elevation needs to be corrected, then we can go for terrain editor. So these are the offering in terms of remote sensing we have for GIS. So for GIS, we have a product called GeoMedia. So that is used for all your GIS analysis or your dynamic analysis. So it has some utility features also, which we're going to showcase later on. So some of the key functionalities of GeoMedia is data interoperability. Basically, it connects to almost all the kind of data sets without any changes directly, without any middleware. So this is one of the key features of GeoMedia. Dynamic analysis is one of the features where your analysis or rules need not to be rerun again and again. It will automatically pick up the analysis, and based as and when your input data changes, your result will also change. So this is some of the key feature of GeoMedia. And within GIS offering, we have GeoMedia Professional that will be for the GIS analysis and some advanced analytics also for like public works utility. Then we have Transportation Manager that will be for your routing and road engineering. Then we have Motion Video Analyst also, which is available with us in case you want to drape your UV images or moving videos. That can also be done. Then we have Advanced Collection, which is mainly for national mapping agencies where your features need to be presented in a very precise and very good manner. So for that, we have advanced feature collections. Now we'll come to the solutions, how Hexagon technologies can help. So some of the demonstration we have created here, so that we'll just showcase here. So these are some of the use cases or uh, features where GIS, geospatial technology or GIS and remote sensing can help you out. So one is use first and foremost is land use land cover mapping. Then you have temporal representation. Basically, you can visualize your data sets at different timelines, how it is progressing, spatial analysis, progress monitoring, maintenance, site suitability, planning. So these are some of the areas where geospatial technology is going to help you out. So I'll just come up. So this is one of the example where your alignment of a railway line is actually designed. So that designed alignment can be overlaid in a GIS environment, and using the latest satellite image, it can be seen. How it will be helpful, that we'll just discuss. So here, the same alignment which has been actually designed and planned is overlaid over the latest satellite images, and along with that, we have the parcel information of that area. So this can be used for acquisition, how much land need to be acquired, how much compensation need to be paid. So this will help you out in that. Same way, using another satellite images, I'll just come to this demonstration video where we see how the progress, how your project are basically progressing, that we can see. So if you have planned a road alignment or a railway alignment, how over the period of time it is getting constructed, so that you can visualize in real time using different images. or different time frame images that can be from satellite, that can be from UAV. It can also be your point cloud images, which will again give you more in-depth information that we'll see in few other slides. Now you can see how the earlier the earth moving was done. After that, the construction of the road and bridges has started. So it has become a metal road now. So bridges work is complete. So over the period of time, how these projects are basically progressing, that can be monitored, tracked, and since these images are basically timestamped, so you can also use it for legal purposes also. So now in many of the court cases, these timestamp satellite images or UAV images are becoming one of the evidence. Next, we talk about, say, natural hazard zonation. So in case of natural hazard, these are mainly because of some natural calamities or because of rainfall or other thing. So in this particular demonstration, we are basically utilizing the elevation data that is available for the area. So we have DEM, digital elevation model. We have slope of that particular area, how the slope is basically going in that particular area. Then we have the aspect, which is basically nothing but the direction of the slope, how the slope is varying and which direction the slope is going. And then we have the soil of that area, what kind of soil is available in that area. So using these different inputs, what we are identifying is we are trying to demarcate the landslide prone area where the probability of landslide is high, maybe because of uh, the slope, degree of slope which is high, maybe because of the soil, because the soil is very soft and susceptible to say because of water it's very soft. So these are some of the area that we can be reported using this geospatial technology. And obviously different outputs, different inputs are required for that, and that can again be generated using the technologies that Hexagon provides. And once you have the information regarding those landslides, that can also be incorporated using these hyperlinks. Another thing that the same different input data is available with you, so you can also use it for site suitability analysis. So we have the elevation, we have the soil types, we have the slope. So what we can do, if we plan any alignment in this area, we can just check the alignment, how that alignment is going. We can overlay that alignment using the same rules that we've applied there, and we can see whether that alignment, how many number of landslide probability areas there in that particular alignment. So that can also be checked. So we have just say drawn a road alignment, so it can be imported as well. So using the same rule that has been applied, it will basically identify these are the probable areas where we may have landslides because of slope and soil type. So these dynamic analysis will also help you out in selecting the site suitability of your area, be it your alignment, be it your road safety, and it can and or accident prone areas. So these are some of the areas where it can be used for. Second thing we are talking about is point cloud data sets. In case you have UAV images with them, so using one of our product called Imagine UAV or DSM Stack, you can create point clouds for any area. So in this case, it can be used for progress monitoring of your project. So here one flyover is basically built up for a railway line. So how that flyover is progressing, what is the uh, depth of that area, was the height of that particular bridge. So that can be, we can visualize sitting in our lab only. So once that data is available, it is available as with again with the timestamp. So you know which date, which time it has been captured, what is the height of the bridge. So these things can be measured. And another thing, because point cloud data gives you X, Y, and Z information, so you can also use it for area calculation, volume calculation. So in case you have piles of construction material, what is the volume of that particular pile? So these can also be calculated and analyzed. Next one comes is for utility network management. So apart from GIS, this is for utility networks management. So It can be used for your water utility networks, electrical utility networks. It can be used for sewage networks. So utility network basically use advanced feature modeling. So using those feature modeling, we can analyze any utility. In advanced feature modeling, we have basically association of each and every object that is there on the GIS. So it can be valve, it can be your pipelines, it can be your main pipeline, it can be your transmitter or transformers in case of electrical utilities. So once you have this association, you can always see the tracing between them. So if say one valve is damaged or closed, how many household or how many different areas are going to be affected, it is going to showcase that area. So if you can see here, I'll just come to the last of this. So if you can see, if we close a valve or if any outage or pipeline brokens, how many households are going to get affected? So that because of the association of between water meters and pipelines and those valves, we can see that how many area is going to be affected by that, and it will always come as a report to you. So those users can be accordingly informed upon regarding this outage. Another solution that comes along with GIS is for transportation. So here we can have basically a road network of any area, and within transportation there are two main solutions that it provides. One is your linear referencing system. So in case of road networks, many times the terms use it in terms of chainage, in terms of milestone. So how we are going to overlay those linear information into a GIS layer? For that we have a linear referencing system. Using linear reference system, we can overlay the events of any network that is there available as a linear feature, like you have a accident or a road maintenance in milestone number 121. So how you are going to identify that in a road layer? So that referencing needs to be done. Once those in referencing is done, you can always overlay your events. Like I said, it can be accidents, it can be your road maintenance, it can be your construction that is going on in any side of the road, or so this will help you out in making decisions in case there is more accident at certain patch of the area, because there is a guidelines by Ministry of Highways regarding the blind spots that is available at highways that needs to be mapped. So that will basically help you out in those blind spot where maximum accidents are happening, or if any kind of measures need to be taken, that can be done using this decision support systems. And apart from these, so these are those overlaid events that is it is displaying here. So next thing that comes with transportation manager is routing. So it is mainly used for routing from say one point to second point. So it will basically optimize the routes, how your route are going to optimize in case you have multiple stopovers. So if you want to go from point A to point B, and with you have say 4 or 5 stopovers, so those kind of features it will provide. So those routing features, it will provide best path. You can have an easy path. You can have cost also included in this. So it will basically take care of those cost metrics as well and give you the optimized part that will cover your whole stopovers and the best path with the minimum cost. So these are the few features of transportation solutions. So then we come to some of the use cases that comes in case of town planning. And so for town planning, obviously land use, land cover mapping is one of the inputs that from where it will start. So we have classification techniques available within ADAS Imagine. So we have unsupervised and supervised techniques. We have some machine learning based classification technique also that will cover. So obviously supervised classification is more preferred because it will you can actually closely monitor your inputs and results accordingly. So how your final results are going to come, you can see that part also. So because you can closely monitor it, so your accuracy will be comparatively more in case of your supervised classification. So you can in after supervised classification, you can always label your classes according to the meaningful name, like what kind of features is available in that particular area. You can always clean up those classifications once we have one set of classification is done. And now with supervised classification, in supervised classification, we have something called machine and learning based classification added since last 2018. So within the spatial model, we have some algorithms for classification where we use machine learning operators, and these models can be trained using the inputs. So in this particular demonstration, if we see, we are using two inputs. One is the image, and second is the trained polygon areas where it has been marked that this particular polygon belongs to this particular class. It can be forest, it can be buildings, it can be roads or water bodies. So here we have this model. So we have training our attributes. Then we'll select the attributes that we're going to use for classification training, and then we can select the algorithm that we want. So in this particular model, it using a random forest classification, but we have other classification techniques as well, like SVM, card, naive basis. So these are to name a few. So I'll just move a little further, and you can see here. So we can select different attributes that we want to use for training our algorithm. It can be mean, it can be min max, it can be median, it can be textures also. This is a very simple model of using classes and mean of the images and then classifying it. But you can make it more complex using texture analysis also. So since high resolution images, texture is also a component which is nowadays widely used apart from normal DN values. So I'll just, so here we are classifying the class names. So this particular column, it is going to use as a classes, and then finally we'll going to run the model, which is going to give us output in MIZ format. So MIZ is basically the trained model. So that MIZ file can be used for classifying other images or the same images, but it should be of the same type. So now using that MIZ that we have already trained, and now we are going to classify the image. So now we have taken the image that we want to classify. We have the MIZ file that is a trained model for classification. And now we are going to classify. So model is run. So once it is done, you will get the output. So here in the another window, you have a classified output using that trained model. So this way you'll get, so this way we can have multiple samples. We can take best part of machine learning is that you can have actually multiple samples. Earlier, we cannot give multiple samples of the same class. So now actually that part is basically taken care in this classification models. So next again, we'll come to say natural hazard zonations, or in this particular case, we are talking about how the spatial data or geospatial data can be used for your drip dam rehabilitation program. So in case of you create a dam, you want to see how much area that reservoir going to cover at different heights, or at the full capacity of the how much area is the particular reservoir is going to take. So we can take that. So and number of villages that is going to affected by that. So that zonation can be done using geospatial technologies. So here again, using the geospatial data that we have created, we have elevation model, we have ortho rectified image, then we have the village data, agriculture fields, and we can visualize it if the dam is basically come to full capacity, how much area it is going to cover, what is the reservoir catchment area, and if any villages are there, so we need to rehabilitate those images. That decision can be taken. So zonation is one of the part where it will be used in planning. You can plan your rehabilitation program. You can plan those villages that need to be actually, you know, moved to some other areas. So I'll just come to another part. So after dam, so we are just talking about the flood. So here also we need to basically zone out are areas which are actually flood prone, which can be inundated by flood. Flood inundation mapping is one of the area where we can use it. So again, elevation model and your satellite images, and along with any village data, urban data, building data, if incorporated, you will get a each and every household that is going to affect in case of the flood inundation. So that flood prone area marking or that flood prone zones can be actually marked out early before any mishappening happens. So earlier what you've seen is mainly from optical data sets. So now because flood majorly comes in monsoon data, monsoon time. So what happens is in monsoon time you have lots of cloud cover. So that time getting a optical image is again a problem. So we can also rely on these techniques called SAR, synthetic aperture radar. So when we have radar data available, which can penetrate through cloud, you can see on cloudy time also what's happening on ground. So same area at different intervals in April 2020, May 2020, and June 2020. So this is for Brahmaputra region. So if you can see how the water is getting basically affecting different areas here, we have some tools that can basically extract out the water from the SAR datasets, and you can convert it as a vector data. And then that vector data and villages boundaries or your building boundaries, if you have, that can be again overlaid, intersected, and it can be seen how much area is getting affected, how much household is getting affected. So it can be used for your socio-economic region also, how much uh, economic damage is done at that particular area. So this is the water body that has been extracted of the SAR data, and the villages are overlaid, that is there in the red colors. Another use case is in case of your change detection. So spatial models can be optimized, created for identifying certain specific kind of changes. So in this particular demonstration, if you see here, it is mainly for identifying the buildings. So it uses the this obviously the DN of the images, plus it is also using the height, because we have incorporated the LiDAR data also along with this. So it uses the height also. So in case there is a change in elevation also, that will also consider it as a change. So nowadays, in case of town planning, if we see, if we have a LiDAR data of 2, 3 different time series, we can see, we can identify the changes. If using the optical images, we can identify if there is a vacant plot, a new building is constructed, that can be identified. If the already a building is or a house is there, but it was a one-story house, now it has become a 3-story or 4-story house. That kind of thing can also be calculated using the elevation data once we incorporate that. So spatial models can design these kind of change detection models. So these its application are various. So we can it will be helpful in planning your say transmission lines. You can actually, if you need to overlay the transmission line in case of power companies, in case of solid waste management, you need to place the dustbins, you need to place the sewage management of that area. For water distribution companies, you need to manage your water pipeline, whether it has that pipeline capacity needs to be increased, a new pipeline needs to be laid down. So, and again, one of the classic example now is city gas distribution, where CGD companies require these kind of informations. How many households are available? How many households might be there? So those estimation can be done. So for that purpose, chain detection is one of the very useful tool. And all those were we were talking about in terms of remote sensing and GIS, and here we are actually talking about the enterprise part of it, how enterprise GIS can help. So in this particular demonstration, it is mainly for smart cities, how the enterprise GIS is going to help the smart cities. So one is that it, because smart cities works on the municipal corporation area, so you can have ward-wise detail of any kind of operation that is going on. You have building permissions pending that can be seen in the enterprise JS. You have open plots here in this case we see. So how many open plots are there available in that particular ward area, how much under construction is going on. So these kind of information are there. We can also add taxation information in these details. in these households. So how much taxation is getting collected, what is the revenue of each and every ward, and within that ward, from how many households, how say certain number of more than certain number of revenues coming. So those kind of things can be done using WebGIS, and this can be open for citizens as well if required, or it can be used for the management of the municipal corporation or smart city administrators. So this is one example where we are basically implementing in Jammu Smart City. So these dashboards will basically or cover some of the citizen-centric application, also the data that comes from citizens, like building permission, sewage maintenance, that will also get incorporated here, and picture how exactly that particular ward is performing, where the problems are there, or where we need to take measures that can help you out, the administrators out there. Again, enterprise GIS or web GIS, as we can say, because enterprise GIS means everything will be available on the web from a central location to everybody. So this is one of the applications which we have implemented in PCMC. So this is mainly for tree sensors, but it can be used for many other applications. So here, if you see, so you have zone-wise data sets available. So for each and every zone, we've selected the zone A. So these are the area where you have zone A, and you can add different another layers also, like tree census data. So we are basically now seeing the tree census of only zone A. So what we do in a traditional GIS, same kind of features are basically implemented over the web. So now each and every type of trees that is available in zone A, it is being listed out here. It can also be exported as a report, which can be sent to different other portions. So here we are now trying to find a specific tree species. So again, for zone A data, and we say we are tree census, and we are identifying the exact number of tree, how many number of tree particular Ashoka tree is available, so that we are selecting here in this case. So zone, okay, zone was not selected here. So this is again example where it can be used for solid waste management, where it can be used for CCTV camera placements, and where it is placed, how whether it is performing or not. So using the mobile application that we're going to showcase in the next slide can be integrated, and we can see the whole picture of any municipal corporation or smart city area, how that city is basically performing in terms of different parameters, in terms of security, in terms of solid waste management, in terms of water, in terms of electricity. So here it is basically now we are creating some dashboards. What kind of dashboard we want, we can select what kind of widgets we are choosing, and based on different attributes we are choosing it. So field officer, who is the field officer? So how different field officers are performing. So it will come as a pie chart. Their overall so different field officers, and these are the output that has basically generated by them. Now we are choosing for in premise trace. So he's showing these are the number of trees which is basically in premise within a particular ward. So these enterprise applications basically gives the GIS data in terms of multiple users at the same times, and so actually everybody will have a same picture. So that is what enterprise GIS does. And second thing it also does is it can basically give the data to the citizens. So citizen-centric applications can also be created using WebGIS. So these reports can also be generated out of it. And the second thing that we want to talk about is basically the applications, how mobile applications that can be used as a citizen applications can be used, or the surveyors. So using this web map mobile that is comes with the enterprise GIS software, GeoMedia web map, we can use it for survey application. So in this particular case, this for tree plantation, for resurvey, for tree cutting permissions. So these are the different applications where it has been implemented for. So here you can see different. Sorry, I'll just go back a little bit, and once login, I'll stop here. Oh, sorry. So you can see different modules has been implemented in this. So you have tree survey module, you have tree cutting permission module, tree cutting flex structure, illegal cutting reporting. So these are some of the modules that actually with the survey we can generate. So here it is working for a particular zone. Said this particular zone it will be working. So zone A, ward number 8. So in mobile application, what happens? The data that is there, it comes whenever you log into the data, it basically downloads the data sets and in the mobile, and whatever you're doing, you can do that. So downloading is done because in mobile you can always also there's a problem of disconnection, because if network goes, so it can disconnect also. So you can work in disconnected and connected mode. So that's why the mobile data will be downloaded. So but once you come to the network again, that data will be synchronized with the server. Here it is, say, tree census is getting done for some plot, what kind of tree is there, what particular family. So these attributes that you see can be pre-filled so that you have a data redundancy. You always have a same type of data available. The chances of typographical error will be minimized. The girth size, trunk, girth, what is the height of the tree. So all these informations are getting filled by the surveyor who is going there on ground. And obviously the photographs, and it also shows you the mobile app that we comes with GeoMedia also gives you the accuracy of the GPS. And we have within Hexagon, we have some as Niladri talked about the Leica portfolio also. So we have some equipments called FLX 100. If connected with this any mobile device, it will give you a survey grade accuracy. So, so, so what we want to showcase is the mobile that is capturing data. It may have some inaccuracies, but using some external GPS antenna, we can create it. We can make it a server grade equipment so that any features that you are basically collecting on ground, that will be accurate in terms of millimeters or centimeter, depending upon the GPS device you are going to use. So right now it was showing 11-meter accuracy. If you have seen that. So again, it can be used for illegal tree cutting, trees libraries. So these are some of the applications that you can create. So smart city cases, it can be used for uh, identifying some of the sinkholes or potholes, or in case of damaged your CCTV cameras or your damaged electricity lights. So these are some of the applications where it can be used for. So with this slide, we'll just come to the end of our presentation, and we can have some time for Q&A also. So I would request, if any questions are there, if whatever you have put in the chat, but we'll try to discuss that. So I'll just hand it over to Divya again. Hi, Divya.
Thanks, Sumit. Yeah, thanks, Sumit. Uh, Everyone, if you have any questions, we will be here for the next 5 to 10 minutes. You can drop in your questions at the question box. Until then, we have one question from Sandhya. If Niladri or Sumit, you can address that, please.
What is the question? Can you please?
Yeah, so the question is that can we apply some spatial model or operators to .NET CDF input data set?
Yeah, NetCDF data is actually recently supported in ADAS. So yes, understanding that the NetCDF structure, we can apply certain operators using spatial models. So I hope I have answered your question.
We have another question. From where we can get the data? Do we need to contact the municipality officer?
Data sets are we are mainly a technology provider, as Niladri has iterated earlier, and I'm just reiterating again. So we are mainly providing technology. The data set will be provided by the respective agencies. It can be municipal corporations, so it can be your mapping agencies like Survey of India, or else you need to create the data using the softwares and survey equipments that we also provide. Any other questions?
Sumit, I think I can add on to some of these question.
Yeah,
Like
please,
first,
please go ahead.
yeah. So first question is that regarding the NetCDF, even in our Luciad platform also we do support the NetCDF. So as you said, yes, understanding the structure of the dataset, NetCDF dataset, we can definitely apply some of the operators and we can do that. Coming back to the municipality, I mean the data part of the municipal data part rather. So as such, GIS data from municipality and as such you call it as municipality officer. So there is no post in the municipality called as municipality officer. So there are several posts like somebody who's thinking about the revenue, somebody is the engineer for the electricity, somebody is the engineer for the pipeline, somebody is the engineer of the roadways. So now depends on what type of data we are talking about. For example, the smart city datas, whatever is there. So these are the collective sources of data. There is not one person who will be, given to the data, and there is no one person called as municipality officer. So when this kind of projects come, even there is a project called Amrut also, where all kinds of municipal data has to be put it into a GIS platform. So whenever this kind of projects come to any particular, we call it as a ULB, urban and local body, be it a municipality, be it a corporation, or be it a gram panchayat. So there will be a board which is to be formed, and that will be formed under the administration of the commissioner or district magistrate, etc., etc., depending on the project and depending on the structure. Now, each and everybody is responsible for sharing their data in their own vertical. Suppose road guys will share the road data, and electricity guys will share the electric data. Revenue guy will share the block wise or plot wise revenue data in terms of tax collection. And then there will be an SI, system integrator, who will bring all this data to a platform, a GIS platform like Hexagon, and all these datas are portrayed in form of maps or different kind of point, line, polygon, vector layers, or thematic analysis in form of pie charts and bar charts into that customized platform. So that is the entire system of the municipal data analysis. So I just think that that should be, answered in a structured manner. So I just added on to it. So Divya, any more questions if we have?
Yes, Nadri. The next question is that what base map does Hexagon use?
So Sumit, would you like to take up the answer?
Yeah, so for within Hexagon, base maps that we use is Bing, but in our enterprise platform, we can add in Google, Bing, OpenStreetMaps as well. So within image processing, we have Bing and OpenStreetMaps.
Most importantly, any kind of commercial platform like Google. So I would
Yeah,
name it as a commercial platform because
commercial
Google has
platform.
strictly categorize their data as for for developmental purpose. Now if you just use those data sets in any of the platform, any of the geospatial platforms, so at the background of the map it is written for development purpose, right? And if you want to go ahead with a commercial, so anybody, you can develop an application on that development base map of the Google. And once it is being done and once we deliver it to the customer, so they can buy, if the customer wishes or if the agency wishes, they can buy a commercial license of Google Map. So our all our Hexagon platforms are base map agnostic. So we do not have any dependencies on base map. Depends on the user's choice. You can use any base map, be it a free or be it a commercial.
Thanks, guys. The next question we have is regarding data sets. Data sets regarding trees are geotagged or it's collected by the local bodies.
In that particular video, what we have seen, so there it was actually geotagged by the surveyor who goes on field, and here because this is for urban trees, so each and every tree is geotagged.
So,
So it has.
Sumit, let me answer this. So basically, this PCMC tree mobile application, what we have shown here. So basically, it is the mobile application developed for the geotagging and collecting the information of the trees. So basically, the surveyor goes to the ground, geotag the particular tree, enter all the tree related information like species, the radius, the girth radius, the girth diameter, and the canopy size, all the height of the tree, everything they measure and they put it in the form, and it will be submitted to the server. So the geotagging, and along with that geotagging, the other database, other information are being maintained in the database. Probably I have answered this question. Hope it's clear.
Yeah, Shashank. Just to be more precise, actually, trees are being geotagged at the time of data collection only.
Thanks, Nadri. The next question we have is with GPS, you would recommend for more accuracy during field survey with mobile application.
It depends upon the accuracy that we want. We have a device called FLX100 from Leica Geosystems that can give you up to 2 centimeter of accuracy. So which is quite good enough. But if you want a millimeter level accuracy, then one more. Actually, we are not the concerned expert on that, but it can give you millimeter level accuracy. So depending upon what kind of accuracy you want, we can suggest the device for you.
Thanks, Sumit. How do we add coordinates in ERDAS for plotting LULC?
Coordinates in ADAS for.
For
So your
plotting LULC.
okay, okay. For LULC, actually, if what we have seen in the spatial modeling, it requires the polygon. So you can use the shape files, and using that shape files polygons, we can use it for classification of LULC.
Just to add it on to Sumit, see, how do we add coordinates in ADAS for plotting LULC? Number one, what I understand is that land use land cover is basically a map that we produce after the classification of any satellite data or aerial data or UAV data. Now, what Sumit answered is a way of classification, how we do using machine learning, or else if you have standard classifier also. Now, if I concentrate on the first part of the question, that is how do we add coordinates. So coordinates needs to be added at the beginning of all the work. That is when you open a blank image in ADAS Imagine, there is one tool called image georeferencing. So there are two ways of georeferencing an image. Either you take any reference image, borrow the coordinates from that image of the same area, and put those coordinate on that particular image which doesn't have any coordinate. Number one, or else you can carry a handheld GPS, or to be, if you want a more precise, you can go with differential GPS coordinates. You can collect it from the various features from the field and insert those coordinates in the satellite data using ADAS Imagine. So there are two processes of adding the coordinate which we call as georeferencing in a geospatial term. One is image to image georeferencing, another field coordinate to image georeferencing. Both can be done in ADAS Imagine, and that is a process to add coordinate on image.
Thanks, Naldi. And the last question we have on the chat box is which method from the hexagon is useful in shoreline extraction?
Sumit?
Shoreline extraction, actually for specifically for worldview data, there is an index that can actually help you out in extracting the shorelines, but that is mainly for worldview data set.
So basically, what I would like to add it on to that, in the coastal zone management organizations, they frequently use this technology. As Sumit rightly said, that we can use the worldview, and there are certain indexes of coastal areas which will help you to identify the shorelines. But again, as you know, shoreline is a matter of constantly oscillating feature. So shoreline is not a constant feature. So you have to use time series data sets to study the shoreline. Generally, we extract the shoreline to understand the variation or the changes or the shifting of the shoreline. So like in Sundarbans, this phenomena is typically done in every season for changes of the shoreline. So where they take the time series data sets and they try to digitize the shoreline. And also they right now they are applying some of the machine learning and try to identify the shifting of the vector using ADAS Imagine. So these are certain techniques that is being applied using the shoreline identification. Basically, um, whatever I have seen, the people who are working on the coastal zone, they do not extract the shoreline just. Normally, the target is that to understand the variation or shifting of the shoreline with the season or with the rise of water level. So for that, they typically run the change detection process to identify the shifting of the shoreline.
Thanks, Niladji. Thank you, everyone. This will conclude today's webinar. Please join me in thanking Niladri and Sumit for this informative session. Please also note the email IDs displayed on your screen in case you may need any further information. We will also be sharing a recording of this session should you wish to listen back to this webinar. We appreciate your time and hope you have found this webinar to be a valuable experience. Goodbye.
Thank you.
Thank you,
Thanks,
everyone.
everybody.
Have a good day.
We appreciate your time that you have joined in. Thank you. Hope to see you soon.